Now let us begin with Raspberry Pi GPIO programming. GPIO stands for General Purpose Input Output. So these are the pins. Raspberry Pi has got 20 by 2, total 40 pins. So these are called general purpose input outputs. So because of these pins, Raspberry Pi can interact with a sensor, read some value, or can actuate something like drive a motor. So apart from being a regular computer, Raspberry Pi can also do those because of these pins. So now let us have a look how these GPIOs are used. So we will be actually doing two GPIO programming. One is reading a button state, so this one, and in next we will read the distance value from a ultrasonic distance measurement sensor. Okay, so in this episode we will be doing reading button state. Okay, so we'll be using this in LED, momentary switch buttons, register, some jumper wires, and a breadboard. So breadboard is needed to build our circuit. So we'll mainly understand GPIO usage, reading and writing GPIOs, how to read and write values on GPIOs, and we'll print some data on our monitor. Okay, so this is the purpose. So let me explain a little about how to use breadboard, for those who are not aware of it. So a breadboard is it helps you make a circuit quickly, because we are not going to use a printed circuit board or something like that. So these are the connections. So you can see these continuous lines. So these holes are all connected in a line. This is also connected in a line, and these pins are connected this way. Okay, so all these holes are connected internally. So this is how a breadboard connection is. So you can use it like this. So there is a channel here. So this is to straddle your ICs across this channel. Whenever you use any IC, you can put it like this. Then you can use this. These are normally used for VCC and ground rails. So some people use like both, one side both the channels are VCC and other side both are ground. Some people use like this, each side the plus one is VCC and minus is the ground. Again here plus is VCC, minus is ground. So if you see here, a battery is connected to this is, so this is the VCC, the red wire is here, and this black wire is ground. So say similarly that ground is connected to here and VCC connected to here. So this rail become a VCC rail, this is a ground rail, and you can see you take the 9-volt power, go through a resistor, and then it goes to the LED, the current goes to the LED, come back here and goes to the ground. So this is how the circuit is completed. So this is how breadboard is to be used. So now let me explain to you the circuit and what we are trying to do here. So our we connect our circuit to the Raspberry Pi to its 3v3 pin. So if you see, we will be connecting to this pin. So this is a 3v3 power pin. Okay, so we'll connect to that, and then we'll put the momentary switch. Okay, and then this momentary switch, whenever it is pressed, we want to read the value on GPIO 24. So GPIO 24 is the ninth pin from this end. Okay, so what we'll do, we'll read on GPIO 24 whenever this button is pushed. So we'll count how many times the button is pushed. Okay, so that is one thing, but there are some other circuit that is done because whenever this this button is not pushed, so you can see this GPIO 24 is actually hanging. It is neither grounded nor connected to the VCC, so it is hanged. So during those times actually GPIO 24 may read something wrong. So what we do, we normally pull it down to ground. Pull down meaning you can use any like 10k, 20k, 100k. 100k will be even better register, and pull it to ground. So when you press the switch, the VCC connection actually don't go this way because of the high resistance, the current flow this way, and GPIO 24 will be able to know that switch is pushed down. But even when it is not pushed down, so switch don't read any arbitrary value because it is now connected to ground through this register. So this is arrangement, this arrangement is called pull down to ground. Okay, and this LED circuit is actually optional only. So why we are putting this, so whenever we are pushing this down, we want to see if current is actually flowing or not. So if current is flowing, then it will also go to GPIO 24, and some part of it will flow through it, but very little part because we are putting a big resistance here. So most of the part will go to GPIO 24, the voltage level will be sensed at GPIO 24, and most of the current will flow through this LED. LED will lit up. So this is what we are trying to do here. So a point of caution here, so we applied 3v3 volt 3.3 volt to this pin GPIO 24. So you can see beside this 3.3 volt pin there is a 5 volt pin here. So please don't use 5 volt pin because the GPIOs are only 3.3 volt tolerant on Raspberry Pi. So if you apply 5 volt, so it may damage the Raspberry Pi. But in our next video we'll see if you have a 5 volt supply, how you can divide that through voltage divider, and how you can still read the value by supplying using a voltage divider and limiting your voltage within 3.3 volt. So I would like to explain a little about these momentary switches. So momentary switches are called momentary because these are not pushed down like so. When you push it down, it just momentarily connects the circuit and then it disengage. But even in momentary touching, there are bounces. So like very fast it touches and detaches. So that happens. So we'll see that when the code runs. Okay, and the connection is such that, so you can see this channel. So these two pins are connected internally. These two pins are connected, but there is no connection between these two. So whenever you push the button here, then these two gets connected for a moment. Okay, so that is why it is called momentary switch. And when we go and build the circuit on breadboard, please mind, so I did one mistake there. So all the circuitry should be there in line with on the breadboard on this pin. I missed this pin by one row. So I put all my jumper wires in the row beside. So when you do it, you just do it correctly. So put it in the same row where your this button pin is. Okay. Let us now do the circuit. So here are the items needed for the circuit: a Raspberry Pi, breadboard, if you male to female jumpers, if you male to male jumpers, a button. Okay, here's the button. Okay, this is a moment switch button, a LED 3mm or 5mm, and a 100 ohm resistor. Okay, so the LED and resistor is actually optional. This is only to show that the button is actually pressed, so the LED will blink. Okay, so let's go ahead. So how to do it? So we actually use this. So now let me have a closer look on the button. Okay, so these pins are actually connected. So you can see this channel, so those are connected. So you need to straddle it across this channel on the breadboard. Okay, so this is it. And then at one side of the button we have one male female wire. Okay, and in the other side also another one. So they are normally disconnected. When the button is pressed, this they feel the they are connected, they get the continuity. Okay, so this will go to the 3.3 volt pin of Raspberry Pi, and this will go to the reader pin, that is pin number 24. Okay, but the thing is, as described in the circuit drawing, we cannot keep it hanging, right? So the same point will actually use a 10k resistor also. So this is a 10k resistor. So what we'll do, we'll ground this point, pull down, okay, to the ground. So this blue channel is the ground rail. So we'll pull this pin to ground. So whenever this button is not pressed, it is not hanging, it is grounded. Okay, so that is called pull down. So that is called pull down. So here it is. And then what we'll do, we will use the LED. Please mind the anode and cathode. The longer side should be in the positive side, and here is the positive side, and here is the negative end, and the negative end should have a 100 ohm resistor and go to ground. Okay, just to limit the current flow through the LED. So this is how our circuit looks like. Okay, so now what we need to do, now let me go down here, focus there. Okay, so this is pin number 24, is sixth pin, 1 2 3 4 5 6. So here, okay, and this will go to 3.3 volt. Okay, and also you need to ground, you should have a ground rail here, right? So I'll use maybe this blue. So ground is the third pin from this side, so I'll ground it here. So this is our circuit. Okay. Okay.